have this pan balance that we're going to use today. Used one of these before? I think it's pretty balanced. All right, let's start. We are going to learn about preservation of equality. The goal is to demonstrate and explain the meaning of preservation of equality concretely and pictorially. So you'll need your notepad or an empty notebook. You'll need a pencil. You might want a pan balance and wooden shapes and some place value cubes and rods. If you don't have those things, go and get them now. As always, to begin, we're going to make connections to preservation of equality. Remember, this is any connection. It can have to do with math. It can be totally outside the realm of math. It can be a very clear connection, or it can just be something that you're thinking of. Write down as many words or pictures as you can in the next 5 minutes. Go. Okay, this is what that might look like. Next, we're going to review some key vocabulary. So as you can see here, the first column shows the vocabulary term. Let's just get this out of the way. So sum is the answer to an addition problem. So for example, 25 plus 5 is 30. 30 is the sum. Variable is a letter symbol that represents a number. 25 plus n equals 30. N is the variable. Difference is the answer to a subtraction problem. 25 minus 5 equals 20. 20 is the difference. Expression is a math phrase. 25 minus 5. That's an expression. A product is the answer to a multiplication problem. 25 times 5 equals 125. That's a product. An equation is a math phrase in which the left side is equal to the right side. So this whole thing, 25 times 5 equals 125, that's an equation. And a quotient is an answer to a division problem. 25 divided by 5 equals 5. Please choose one of the key vocabulary from the previous slide and fill in this definition placemat. So you can see there's definition, that's where you write in the definition. The middle part there is where you put the word, then the definition, then using that word in a sentence, then what do you think about, and draw some sort of an image. One of these words. Okay, this is what this could look like. This is a placemat, vocabulary placemat for the word variable. Okay, so this is a pan balance. You can see there's a picture on the slide as well. Have you used this tool? What is it? How is it used? What does it measure? Can we use this simple drawing to represent a pan balance? So if we have one base 10 rod on the left side, then how many base 10 unit cubes will balance and equal the mass of the rod? So if I have one of these, how many of these need to go on the other side to balance out the scale? Write down your prediction. Okay, so you should need 10, right? One rod equals 10 unit cubes. I notice here that in my solution, I've written 10 unit cubes equals 1 unit rod. Do you think it matters which is on which side? So it actually doesn't. I think that this would be more clearly communicated if it did correspond to which side. But when we're talking about equals, we're just saying one side equals the other side. It doesn't actually matter what side of the balance it is. Okay, here's another demonstration. I have put a combination of rods and units onto one side of the balance. If you're in class, you're going to actually come up and add units to the scale until there's equality. Here, we'll just watch this. Okay, look, we put on 20 unit cubes and now there's equality. So what do we think is behind here? Could also be 20 unit cubes. In this case, it was one rod and 10 unit cubes. So 1 rod plus 10 cubes equals 20 cubes. What about this demonstration? How many rods and cubes are needed to balance this cylinder? And again, if you're in class, we can actually do this, but we're going to watch this. So ends up, we need 6 rods and 1 cube to balance it. Pretty exciting. Here's a video demonstration that you can watch. We're going to skip it in this video though. Please go back and watch it. It's great. And here's another example. So what do we see? We see 4 cubes equals 4 cubes. 4 equals 4. What if I removed 2 cubes from one side and 2 from the other side? Will the scale still be balanced? Yes, it will be 2 equals 2. What if I link the cubes together on one side, but leave them apart on the other side? Will it still be balanced? Yes, them being linked or not doesn't change the weight. What if I take away 3 blocks from the left side and leave the other side? Will it still be balanced then? No. What do I need to do in order to restore balance and preserve equality? Well, I can either put those 3 blocks back, or I can take 3 blocks off the other side. So the key here is that to keep the balance, if you do something to one side of the scale, you have to do the same thing to the other scale. So here's another example. 3 cubes equals 3 cubes. 3 equals 3. So what about multiplication and division? Well, if I add 6 cubes to one side, I now have 3 times as many cubes on that side, right? So 3 plus 6 is 9. 3 times 3 is 9. So really, I've multiplied the left side by 3. So what do I need to do to balance the scale? Well, we need to multiply the other side by 3 as well. So 3 equals 3. 3 times 3 does not equal 3, but 3 times 3 equals 3 times 3. And that's what this is showing, right? 3 times 3 does not equal 3, but 3 times 3 equals 3 times 3. Or simplified, 9 equals 9. So let's do some guided practice. We can see a problem here. On one side, there is 8 cubes. On the other side, there's 5 and a question mark. So this is easy, right? There are 3 cubes in the bag. This is a simple equation. We can mentally solve it. However, sometimes we can't mentally solve an equation, like this one. 4 bars plus 5 cubes equals 1 bar plus 3 cubes plus some sort of a variable. So we can write this down as an equation. 45 equals n plus 13. Then, to keep both sides equal, we do the same thing to both sides. So in this case, subtract 13 from both sides, and then you've isolated the variable. 32 equals n. There you go. All right, so to practice today, there's a handout worksheet. It looks like this, and there are a bunch of problems where they ask you to isolate the variable and solve the equation. The key problem is called mystery numbers. The following problem can be solved using the equation. Read each problem, write the equation, and solve it. Remember to represent the mystery number with a letter. So for example, Margaret's thinking of a number that is 25 less than the sum of 100 and 200. So 100 plus 200 minus n equals 25. 300 minus n equals 25, so n has to be 275. Here is your mystery number. Jake's mystery number is 15 less than the sum of the digits in his telephone number. His phone number is 964-2199. What is Jake's mystery number? Thanks for watching. I hope that now you can demonstrate and explain the meaning of preservation of equality concretely and pictorially. And remember, isolate the variable, do the same things to both sides to keep equality.